and welcome. We are delighted to have you join us. My name is Amber Bryant, and I am the project manager for the Partnership for Expanding Education Research in STEM, the Pierce Data Hub at the University of Michigan. The Pierce Data Hub is funded by the National Science Foundation and is a collaborative initiative between the American Education Research Association, AERA, and the Inter-University Consortium on Political and Social Research, ICPSR, here at U of M. The Data Hub features ways to explore and discover data sets for secondary research analysis, avenues for connecting with colleagues and like-minded researchers, and resources for data and research management. If you would like to know more and also register for upcoming webinars for free, such as this one, please visit the Pierce Data Hub website at www.piercedatahub.net. A few quick technical notes before we get started today. This webinar will be recorded, and the recording and slides are, when they become available, a message will be sent to you via the email that you used to register. We hope that this doesn't happen, but if the webinar were to close, please reopen it using the link that was provided to you in your email. Please type in any questions at any time using the Q&A box on the bottom of your Zoom window. A live transcript is available. To show or hide that transcript, click the up arrow on the live transcript button. Please note that for those viewing on a phone or a tablet, the Zoom app currently highlights only the active speaker. The live transcript will still be available. You may need to scroll to the left or the right to see the presenter or the presentation. For privacy, all participants are in listen-only mode with microphones muted, and chat between participants is limited. One last note, if you are posting to social media about what you learn here, please use hashtag Pierce Data Hub. Once again, this webinar will be recorded and a link will be sent to you via email. Okay, today we are hearing from Dr. Barbara Ericson. Dr. Ericson is a professor of electrical engineering and computer science at the University of Michigan in the School of Information. She has been recognized for decades for her work and dedication to advancing computer science, specifically as it relates to increasing diversity in the field. I thank her in advance for coming and speaking with us today, and I really look forward to what she has to share. And I'm going to double check and make sure that she has everything she needs. So give me 1 second. Sorry about that.
Screen sharing isn't enabled. Can we enable that?
Absolutely.
There we go. All right. All right, so I'm going to talk to you about how I'm trying to improve diversity in computing by increasing access and success. I am an assistant professor in the School of Information. So this is me and my first job, so if you can find me. What I want you to look at is how many women there were. And this was in the mid 80s. So that was actually the peak of women in computing. We had about 36% of bachelor degree recipients in mid 80s, 85, 86. And then it dropped and it got pretty low, but it started to slowly come back up, but it's nowhere near where it was. In fact, my second job, this was my first jobs at down in Warren at the General Motors Research Labs. And this is back in the day when we were in with the computers. So we had great big computers, a great big computer room. We were there with the computers. And then my next job was at Bell Communications Research, and I was on a team of 8 programmers. We had one guy, we had a token male. So computing, when I first started, was much more female than it became later on. And I did a bunch of other things. I worked at a bunch of industry labs, but then in 2004, Georgia Tech hired me to be the director of outreach for them. You know, the dot-com bubble in 2001, we had a bunch of people interested in computing, then the dot-com bubble happened and people disappeared pretty quickly, didn't come into computing anymore, and the gender balance wasn't good. And then the job started picking up, but the people didn't come back. So my job for a while at Georgia Tech was to try to grow more people, get more people interested in computing, get more diversity in computing. So I did things like lead teacher professional development, trying to work with teachers to get more teachers to know about how to teach computer science, worked with over 500 teachers over the years. I made summer camps. I figured, all right, let's try to figure out what I can do to get kids interested in computer science, keep them interested. We tried a whole bunch of different things, these cute little Pleo dinosaurs, all sorts of stuff, robots. We did weekend workshops with Girl Scouts, Black Girls Code, etc. We did a lot of curriculum development. There were 4 courses in Georgia offering computer science, and the courses were really not great. So we revised those courses. We got AP computer science to count as a 4th science for graduation. So that really increased the numbers. And we used to run competitions using drag and drop environments, Scratch and Alice, for anywhere from elementary to high school. So those are some of the things I did. We had a grant called Georgia Computes from 2006 to 2012. So that was a big part of that. We also were trying to get more university level people to teach in better ways too. And so there were 2 of us that had these BPC alliances. Ours was Georgia Computes, and then there was a Kate one in Massachusetts. And you can see our curve, this red curve here, was for us in Georgia for how many people are taking advanced placement computer science. And you can see the uptick also for Massachusetts because we were putting a lot of work into that. And you can see other places were fairly flat or up a little bit. So we felt like we had made some progress. But when I if I broke things down in Georgia by numbers, you can see we had good progress. We went from about 400 in 2006 taking the exam to 1,000 by 2012. And in general, pass rates fluctuate a bit from year to year, but 38% to 56%. But when I got down to this and said, what % of Black students pass? I went, oh no, where only 3% of Black students pass compared to an average pass rate of 38% that year. That's not good. We need to do something about that. So I created something called Rise Up for CS, originally aiming at Black students. And we offered them near peer role models using undergraduate students to lead help sessions. We did both remote and in-person help sessions. In-person help sessions, we would also provide food. So this is me with some of the original cohort. And I started creating interactive ebooks. In fact, the book that's become CS Awesome got started because I created it for Rise Up for CS, because it was working pretty well for us in Georgia, and I wanted other institutions to try it. And I found that some of the other institutions didn't always know what was on the exam or didn't know Java that well. So I started creating that book to help other institutions run it, as well as for my mentors to run it. Over the years, we eventually opened up Rise Up to be for all underrepresented. So all women, all men that identified as Black, Hispanic, Native American, Pacific Islander. And one of our students that was in Project Rise Up, I saw him when President Obama came to Georgia Tech to give a talk, that he was right behind him. And I was like, oh, that's so cool. And what did Rise Up mean to you? Because I've been meaning to ask them about that. And he said it gave him this direction in life. He had no interest in CS, but taking that program, he desired to take a computer related field, ended up coming to Georgia Tech. And several of those students, I heard that story over and over again. I wasn't interested in computer science. I didn't expect to do computer science, but by being in Rise Up or Sisters Rise Up, we also did targeting at women. That showed me people that had been in computer science as near peer role models who were doing internships at Google and Facebook and Microsoft. And I went, hey, if they can do that, I could do that. So in general, what happened then? So we started running Project Rise Up about here, 2013. As you can see, the number of Black students who are passing the exam went up, the pass rate went up, which we were excited about. And this is when I left Georgia Tech, and because I finished my PhD and then moved to the University of Michigan. They did run it a little bit after I left, but I think they've stopped. So you can see a drop again, potentially. Number of Hispanics, started increasing. The number of women who passed more than doubled in a few years. Can't claim it was all due to us. There were certainly other things going on, but we do feel like we had some effect. I actually compared Georgia and Michigan because there's similar population sizes, even though Georgia has a larger population of Black students than Michigan does. But still, During that time period, Michigan never had more than 12 Black students pass ICPSR versus 69 in Georgia in that time period. Michigan had 216 females pass the exam up to 2018 versus 309 in Georgia. Michigan had a lot less exam takers than Georgia. So potentially there was some impact. And there's been a second, there's the CSA exam is equivalent to a college level CS1. So it's object-oriented programming in Java. And that's a big lift for a teacher that's never had any programming to be able to teach at that level. So there is a new CS advanced placement exam called CS Principles that started in 2017 with the goal of hoping to make that much more diverse, but is it really, right? So this is a scale where this center line is even male and female. So if the same numbers of males and females took the exam, they'd be along the center line. Everything to the right is more females than males. Everything to the left is more males than females, and it's a log scale. So the worst is physics, electricity, and magnetism, but CSA is the second worst as far as male skewed exam. Then there's physics again, physics, and then CS Principles. And then another physics, and then economics micro, calculus BC, music theory is up here, and we start to get to the even. And as you can see, the size of the dot is how many exams get taken. So really the majority of exams are female heavy. So a lot of these big exams, English language and composition is majority, more females than males. And the most female skewed are the art ones, drawing, 2D art, 3D art. Those are the highest skewed female. And then are all equally succeeding in advanced placement computer science. And in general, in all of the advanced placement computer science, we see this achievement gap by race, that Black students tend to have the lowest, then Hispanic, then white, then Asian. And it varies for different exams. This is CSA, this is CSP, this is calculus, this is US history, this is biology. But we see this over and over again. So I don't think that has anything to do with innate differences. I think that has to do with our education system and historic problems with it. Oops, sorry. A number of exams, there has been big growth for CS Principles to go from nothing to over 100,000, but it's still way smaller than the biggest exams, which are 250 or close to 300. So there's still a long way to go. So one of the problems I ran into when I was working with a bunch of teachers is I could teach them interesting ways to teach computing, but they could buy books but once every 7 years, which is not great in computer science. So one of the things we wanted to do is create free books, online books, especially, and add new ways of practicing than just writing code from scratch. So we found Brad Miller. Actually, my husband and I got a Karlstrom Award, and at the ACM award ceremony, Brad was getting an award as well for some of the work he had done in recommending systems. So we met Brad, and he had started this Runestone Academy because he wanted to democratize textbooks for the 21st century. He wanted books to be free so that you could learn computing if you couldn't afford the $200 fee for a book. And he started with one book back in 2011. Now there's over 30 free ebooks for both computing and math. There's an average of 2 million page views a week. It's one of the top 1% of websites in the world. And we started creating interactive ebooks on Runestone, following principles from educational psychology. So worked examples plus practice. I give you working code that does something, and then I ask you questions about it to get you to think about it. And I'm going to switch to 1 second and show you that live. So some of you may be familiar with turtle graphics. So Seymour Papert way back in the 60s had this idea of a robot turtle that had a pen in the middle, and students here had a button box and they could push a button and make it go forward, turn left, turn right. And Seymour thought that computers were the best thing ever because you could play with it, and it could take on, it could be text, it could be images, it could be all sorts of things. So this is a worked example. It's working code that does something, and you can run the code, you can modify it, and it creates a turtle and tells the turtle what to do, go forward, turn right, turn left. And then we have questions to ask you about that, like which way does a turtle face when it's first created? So it's going that way first, so that would be east, and you can check immediately to see if you're right or wrong. And then this is what I did for my dissertation is, okay, rather than just make you write code from scratch, I I want you to give you practice, and I also want you to think about that example. So here I've given you the correct code to solve a different problem, to draw this picture, but it's mixed up like refrigerator magnets, and you have to drag them over here into the right order. And there's pairs of correct and incorrect code. So if you can see this, it says from turtle capital I import versus from turtle lowercase import. So I may have to go back and look at that example and be like, okay, oh, it's a lowercase import, but notice, screen and turtle are uppercase because they're class names. But you may not know that, right? And so it might be something you might ask about. So I have to create a screen and a turtle. And then I normally go east, so I'd have to turn right. And then I'd go forward. There's a long side and a short side. So there's 150 and a 75. So I'll do the 150 first. And then say I grab the wrong block. When I check it, it'll highlight any blocks that are wrong. And so I want to forward there. So in general, my early research showed that people liked this. They thought it was easier than writing code from scratch, but some people really got stuck. And so if they were stuck, I still wanted them to get to a correct solution. So if you are trying to solve it and you're having a lot of trouble, so I'm trying to solve it and I have to keep trying several different things and I'm not getting it right. So then it pops up after 3 incorrect attempts, it pops up to say, hey, I can make this easier. So if you hit the help me button, if I used any of those incorrect blocks, first thing it'll do is get rid of that. So it'll animate going back, repair with the correct, which is a hint, hey, use that. And keep doing that till I get rid of all my incorrect blocks. And I don't have to keep saying I want help, but if I do want help, I can do that.
Ericson, could you zoom in on that a little bit more, possibly?
Just a second. After it does this, I can zoom a little more. Yeah. Whoa, 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 whoa.
Thank you. Oh, almost.
Wait a second. Now I've gone so far, I can't see it. Okay, try again. All right. Is that better?
Yes, that's better.
Okay, I'll reset and do it again just so you can see. So I'm just going to grab a bunch of them just to show what happens. So check it. If I'm make a change and I'm still wrong, make a change, I'm still wrong, then I can use the help. If I have a wrong block, it animates going back, pairs with the correct block. And then if I still need help, it'll start combining blocks that are the furthest apart. So one block moves up to the other and then it redraws as one block. And I can keep doing that until I get down to 3 blocks. Then it'll tell me, okay, come on, 3 blocks. Actually, it's already in order. And I could reset and do it again if I wanted. So go back to here. So that's the kind of thing we were doing. Those are, I call those adaptive Parsons problems because they dynamically adapt the difficulty if you're having trouble. I also affect the next Parsons problem. So if you solve the last one if you struggle to solve the last one, it'll make the next one easier by pairing distractors, getting rid of half the distractors. If I solve the last one very quickly in one attempt, it'll make the next one harder because we're trying to keep you in Vygotsky's zone of proximal development, which is where you're challenged to do more than you can do by yourself, but you can do with help. And that's where learning is maximized. Okay, so go back to slideshow here. So originally I got excited about these because I saw a paper at a conference about Parsons Problems. So I started adding them to this ebook that we were creating. And I found that more people tried to solve them than to solve nearby multiple choice questions, but some people really struggled to solve them. That's why I made them adaptive. Because I was thinking about doing this for my dissertation, but I didn't want to do it for my dissertation if nobody was actually going to try to solve them. But people did. And then I conducted studies during my dissertation work. So tried solving Parsons problems, the mixed up code problems versus fixing code with the same errors as the distractors in the Parsons versus writing the code from scratch. And it was a between subject study with undergrads. We had Parsons condition completed the practice significantly faster than either the right code or the fixed code. Actually, fixed code was the worst, with no significant difference in learning gains from pre to post. So there was learning gains from all 3 conditions from pre to post, but no significant difference, but faster. So yeah, we just talked about adaptive, the intra problem or same problem adaptation. If you're struggling to solve the problem, we can remove distractors. We used to provide indentation, but we've gotten rid of that because some people got confused by it and it doesn't seem to be necessary. So we've gotten rid of that now. It just removes distractors or combines blocks. And we already showed that. And then if the last, then we have inter or different problem adaptation, between problem adaptation. And so we can either make it harder by or make it easier by don't show the distractors as pair. That's harder. Make it harder by don't show distractors as paired and use all the distractors, and then versus remove some of the distractors and pair the rest. So trying to make it easier. I did an observation study where I had teachers work through several chapters of the ebook on their own, and then I observed them as they work through this chapter on turtle graphics. And they solved a lot of Parsons problems before I asked them to fix code and write code. And I did see them use the Parsons like they would use the distractor with the wrong case or use the distractor that was missing a colon. In fact, one teacher said to me, "How come you have the same code twice?" And I said, "Oh, it's not the same. One of these is missing a colon." And he kept using the one that was missing a colon, and then he'd notice it was a distractor, and then it, with the adaptation, it would get rid of it. So when he got to the fixed code problem and it was missing a colon, he went, colon, which is part of what I want people to do, is learn to recognize those errors. I did another study of adaptive Parsons versus write code where I had a control group that did something off topic, and the people in the Parsons condition were significantly faster than the write code condition. There was a significant difference in learning gains for the adaptive group versus the control group. And then I put a bunch of Parsons problems in several books, some of them adaptive, some of them not. And then we looked at the log file with over 8,000 unique users, and we found that people were nearly twice as likely to correctly solve adaptive than not adaptive. So the adaptation seemed to be helping people get to a correct solution. And about that time, this book that I had created that now is called CS Awesome for Rise Up for CS, for people taking Advanced Placement Computer Science A, I was contacted by the mobile CSP group, so Beryl Hoffman and Jen Rosato. And the book, I hadn't had a chance to work on the book for a while, and the A course was changing, so they asked if they could modify the book and bring it up to date and add new content. And I said, sure, that'd be great. And their focus is on teacher PD, and after I got my PhD, my focus is not on that so much. So it's great because they created a teacher group with over 2,000 teachers in it. There's over 2,000 custom courses that were created in 2020 from this book. We had over 30,000 registered users. And then Aman, who is a student of Paul's, was working on Runestone, and he added a space practice tool, which is consistent with desirable difficulties, that practice is good, but it's better to space it than to mass it and do it all at once for learning, for long-term learning. So he made a space practice tool that pulls pieces from the interactive ebooks that you've already covered after you've covered them. And you can, as the instructor, you can assign people to get X points for solving Y problems a day for over Z days. And then, so it predicts when you're about to forget a topic, bring back questions from that topic. And every hour of practice was associated with 1% increase in the final grade. And then one of my PhD students, Catherine Cunningham, was focused on people learning how to trace code. And one of the things she found that was very interesting is a lot of students in the School of Information didn't want to trace code. They said, I'm not a computer. I don't need to think like a computer. They don't want to be software developments. They liked learning more. They wanted to learn real world code, but they didn't want to get down to that low level detail. So she created something she called purpose first programming in the ebook. And there's an example of that for Learning Beautiful Soup, where she had them first sort of create Parsons problems for ordering the plan goals, and then had code where some of the code was missing to sort of get them to think about slots or things that are changeable in the plan, and then fill in the plan slots for the code. And she was able to get students through a curriculum in 20 minutes. And they felt like, wow, this is a great way to learn. So that was very positive. Another of my students, current students, Carl Hayes-Magar, is been looking at cognitive load, as well as still continuing to look at the efficiency of Parsons problems versus writing code. And he conducted a within subject study with undergrad students. In general, this was the self-reported cognitive load. They reported lower mean cognitive load for Parsons than for write code, but it wasn't always significant. Usually there was a lower median time to solve for Parsons, but not always significant. And especially if the solution was unusual, if the solution did not match the way that most of the students who wrote the code first would write it, they both reported higher cognitive load, and it took more time. So that was very interesting. He also did a think aloud observation of 11 students, some of whom said they hate Parsons Problems, they'd rather write the code themselves. And he just ran a study with neurodiverse students using the ebook to see what benefits and challenges they face. So from that, of most people, and in general from end of course student surveys, because I use Parsons Problems a lot in my course, we see that most students, and this is consistent with prior research, like Parsons Problems, like 75 to 85% say that Parsons Problems are helpful. But especially students with more prior experience would rather write the code themselves. So we've added that ability. So if you're given a Parsons problem, we have a toggle at the top. You can toggle to the equivalent write code problem with unit tests. So if you'd rather write the code yourself, go ahead and do it. It's meant to be scaffolding, so it's fine for scaffolding should fade or disappear as you improve. So that's one thing we've added new. Another thing I have another student who's working on is horizontal Parsons problems, because most of the Parsons problems I've been doing are vertical. They're, drag blocks into vertical order and then organize them into 2 dimensions for indentation. But some things in computing, like regular expressions, are just creating a horizontal set of blocks, or for SQL statements, or for just putting one line of code together. And so she's created a horizontal Parsons problem tool for Regex. And then she conducted a within subjects think aloud study and found, just like normal Parsons problems, that students tend to think those are easier than text entry. But again, they're more limiting. It may not solve it the way that you want to solve it. In a MOOC, she put this in a MOOC as a voluntary assignment. The text entry condition had a significantly higher dropout rate. So the Parsons condition kept more people in to the end of the study because people were told they could drop at any time. Parsons condition, the text entry, we lost a lot more people. And the Parsons condition had a higher learning gains on the meaning of symbols and took less time to complete. So similar to what we saw with vertical Parsons problems. Another exciting thing we're working on is, okay, writing code from scratch, what do I do if I'm stuck? And this is a real problem for a lot of people. And we thought, hey, what if we can pop up a Parsons problem? We don't want you to be able to switch to it like the opposite. So if we give you a Parsons to solve, you could go ahead and write the code. That's considered harder for a lot of people. But if we give you a write code problem, I don't want to let you switch to the Parsons, but I want to let you use it as a hint. So you can pop it up. You can just look at the blocks and use that to figure out what you're supposed to do. You can solve it, but you can't just copy paste the code. Even if you solve it here, you would have to at least retype it. So we're currently trying that out. And I just got a career grant because we can look at what student written code is, and we can find out what's the most common solution, because our other research shows that it's important to use the most common student solution. So we want to generate Parsons problems from the most common student solution, but then what if your solution isn't the most common? So if you're writing code and you're stuck and you're not using the most common solution, can we generate on the fly a dynamic personalized solution, one that where the correct solution is closest to your incorrect code, and then serve you a personalized Parsons problem? So that's what we're gonna do in the future. And this is the student Xingying that's working on that, and Zhuang is a professor in the CSE, and so she's working with us too on that. So far, we've done a think aloud study, found that different people use it for different things. So, and we've done a between subject study. The group in the Parsons as hint condition had better learning gains on write code problems than the people in the write code condition with no Parsons as a hint. And then another of my PhD students is working on a social justice project, author. She's done semi-structured interviews with 11 students. 63% say computing lacks communal applications, which is one of the things that women and minorities are more interested in. Most students wanted more homeworks and projects with social justice context. So we had created one homework, and then we asked about that. There was some tension between just trying to get their work done, get their points, versus we're asking them to think critically about how things are working. So he's working on that. And then one of the things I've also been working on is one of the things that we have a lot of evidence for improving student outcomes in these large lecture classes is something called peer instruction, developed by Eric Mazer from Harvard. And what it is he noticed when he lectured in his large classes at Harvard that students could answer the tests. They could spit back to you what they'd done, but they weren't really thinking critically about it at all. So what he started doing was displaying a very hard multiple choice question, having students vote individually, then discussing it with peers and then voting again. And I started doing this. I'd learned about this at several conferences. It's also one of the things we have a lot of good evidence for being effective in computer science. And if you're going to do nothing else, it's a good way to break up lecture, because we know research has shown that students stop paying attention to lecture by 15 minutes, you've lost them. So at least every 10, 15 minutes, you should bring them back by doing a peer instruction question. I found that students liked it, but they used to have to use the iClicker devices, and that was real problematic because they would forget their iClickers or they'll run out of batteries, and I'd have a group of 5 students after every lecture wanting to make sure they got their points, and they were driving me nuts. And there's no reason why we can't just do this in the ebook. So we've added that ability. I got a grant to do this, and we've added it to the ebook. So Runestone now has support for peer instruction questions. This is the instructor interface. So when I come into this, I can stop the vote, because as soon as I come into it, it starts the vote. So people can vote. I can see how many people have answered. I can stop the vote. It'll count down. I can enable discussion, which actually pairs people, trying to maximize the number of people that have different answers. And then they have a chat window where they can discuss. That way I wanted to handle people that were remote. And then I can start the second vote. I can, again, watch how many people have answered. I can stop that vote. And then I can show, there's a button usually to show the graph. And I can see the 2 graphs side by side. What did people answer? It's a histogram, ABCD, and versus the first time versus the second. And this is where they can type their answers and see what their peer has answered. So we just trialed this into a 6th this semester. We're still analyzing the data. In general, students liked being able to vote in the ebook. They liked being able to see the question right here, because of me just displaying at the top of in the front of the classroom, they couldn't always see it that well. So they liked that they saw it on their local computer. They liked being able to vote. They could vote on their phones. They could vote however. They didn't discuss as much with this. So we may do some mix of this. And then, because I'd run Project Rise Up and Sisters Rise Up, I actually started it once I got here to Michigan. I started it here in Michigan again, Project Rise Up. And then Sisters Rise Up, we got some funding. Actually, I'm going to talk about that in a moment. So let me switch. This one's about Renew CS. Because of running Rise Up, though, I was interested in running a mentoring program for undergraduate women. So we started that this last year. It's part of the Center for Inclusive Computing, or CIC group. We have funding from Northeastern, I think it is. And the idea is to help women or non-binary people succeed in introductory computer science with near-peer mentors, just like in Sisters Rise Up. And I've been adding more interactive ebooks to try to help them as well. We only had 25 mentees in fall 2021, but by winter we had 87, so a lot more. And we're going to continue working on that. I'm also creating online courses because I want, particularly trying to reach teachers that have taught CS Principles, and CS Principles is that new advanced placement course that's easier than the CSA course. It's more like a first course for non-majors. So it does cover some programming, but just a little bit, variables, loops, conditionals, functions. So I actually created this online course in part because I wanted the CS pre-teachers that had been teaching CS Principles to have something that they could transition to textual programming in Python. Also for CSP students that had taken AP CSP, but their school perhaps doesn't offer A, and they want to learn more about textual programming, or for conversational programmers who don't want to be software engineers. It's not lecture-based. There's a lot of open-ended creative assignments. We use the interactive ebooks. We encourage social interaction. And then this is Sisters Rise Up. So when I moved here to Michigan, I started Rise Up and Sisters Rise Up here. Originally, we just targeted Michigan, but then I've opened it up, especially with COVID, I opened it up to anybody, anywhere. So 2019, 2020, we tried to run it at 4 states. This was individual universities trying to run it for just the people in their state. We only got 17 women of color to enroll. That's who we were targeting. That's who we'd gotten funding for. We had trouble with recruitment, trouble with the IRB, trouble with trying to keep all the 5 sites doing the right thing, same thing. So 2020, 2021, I decided to just run at the University of Michigan. We had 19 women of color. All the help sessions were remote because of the middle of COVID. One of the women, a Black woman from 2021 said, I'm so grateful. So she was elated to see her score. And then so we ran it again, 2021, 2022. We actually ended up with more than 55, I think. Now I haven't updated these slides, but 21 states, better attendance than last year. So I think this could really grow and reach a lot of people. So I'm very excited about it. I do want to bring in a partner on the West Coast because we have students that enroll on the West Coast, and I want to have help sessions later in the day. All right, so my future plans, try to increase access. I'm going to finish my online course by summer. There's already 2 of them are done. It's a 4-course sequence. I've finished 2. I'm working on the last. I've actually finished the 3rd one. It isn't up yet. And then I'm working on the 4th one. I'm going to continue creating free and interactive ebooks because I think that's the future. I think it's very important. I want to increase success by increasing active learning. So the use of peer instruction, Parsons Problems, ebooks. I want to grow Sisters Rise Up, create more social justice homeworks and projects. And eventually my sort of long-term goal is, can we detect struggling students, which in some ways isn't that complicated to detect who's struggling, but also provide personalized assistance to try to help get them caught up. So in summary, I'm trying to improve diversity by increasing access and success through early and engaging exposure to computing, mentoring programs, developing more teachers, using more active learning. And here's some URLs and bar chart thingies, whatever these things are called, that you could use if you want to go look at some of the ebooks we have on Runestone or go to any of the online courses. Oops, I guess I shouldn't have stopped sharing. I was going to go look at is there a link to the social justice project? Is there a link to online CSP course materials? Okay. So there's no link. I don't have or I can click answer live. I'm not sure how to do this. Done. Is there a link to the social justice project? No, that's one of my students. So I can put you in touch with my student if you're interested in that. Is there a link to the online CSP course and materials? So yeah, the Runestone stuff. Let me go back to this. Nope. So here's a link to all the books on Runestone. There is a CS Principles book on Runestone. There's also mobile CSP.
One more question for you, I believe.
I see it now. How's the study with neurodiverse CS students going? Well, they weren't all CS students. So my PhD student is just finishing his dissertation. So he's written up that chapter and some fascinating things. One of them was the neurodiverse students, all of them that were in the study, and this was a small multi-case study. So he ended up with 5 students going through the ebook and giving him feedback from each week and doing surveys and things. And all of them wanted the ebook as on paper, which I was really surprised at, but they said that's how they take notes in the margins. They highlight stuff. They don't like tools to be online. They also find being online distracting because if there's any ads or just being on the internet in general, because they can always open another window. So people with ADHD said it's not good for me to do it online. I'd rather read in paper. So we're actually moving all the Runestone books over to something called Pretext that the math teachers have been, textbook authors have been using for a long time. And one of the things that gives us is the ability to dump a PDF. So I'm excited about that. The neurodiverse students, one of them, it was very interesting. Anything to do with numbers could cause focal seizures. So that was interesting. I didn't know about that. And we could write our examples in ways that avoid use of numbers. We don't always have to use numbers. So that was interesting. They did appreciate being able to go through the ebook on their own pace. They said, trying to learn computer science in a classroom where you're trying to be keeping up with everybody who's not neurodiverse was too much pressure. They liked learning through the ebook. They thought the practice was interesting. They liked the adaptation.
The first question, I'm sorry, Dr. Ericson, was the one that's in the chat where it says, could you elaborate on the theoretical base of your argument?
Oh, okay.
Diversity. Yeah, I just wanted to make sure I didn't miss that first post.
You're right. I didn't see that piece. Okay. Could you elaborate on the theoretical base of your argument near peer role models? So there's been several studies that show that students, what influences students. And one of the things that influences especially students is near peer role models. I like the statement, you can't be what you can't see. I made a mistake one time in our summer camps because I wanted to make sure that girls felt welcome in the summer camp. So one of my summer camps, I only put pictures of girls up from previous years. And I had a parent call me and said, do boys like this too? And I was like, oh no, yes, of course boys like this. It's about robots. So I was like, yes, the boys love robots. What are you talking about? But you have to be careful about that. You have to make sure you show everybody, not just one side or the other. So the theoretical base for that is feelings of self-efficacy you may be familiar with, or expectancy value theory from Eccles, or self-efficacy from Bandura. And in general, you take cues from society, from your culture, about what kinds of things you should do, what kinds of things you should value. So in computing, unfortunately, because the stereotypes are that it's mostly for white and Asian males, women and minorities tend to feel like they don't belong in computing. And so by having near peer role models, seeing people like themselves who do feel like they belong in computing can change their mind. So that was a little bit about that. Interactive ebooks is about active learning versus passive learning. And in general, poor teaching affects underrepresented students worse. Women in particular are more sensitive to grades than men. So women leave computer science who have better grades than the guys who stay, because women see poor grades as an indication that they shouldn't major in something, whereas guys sometimes will brush off a poor grade as it's not my fault, it's the teacher, it's whatever. And do you have any evidence that these measures also work to foster STEM diversity at college graduate level? Yeah, I mean, there's a bunch of research that you could look at about how do you improve help sessions, all the research we did in Sisters Rise Up, Project Rise Up, but other people have also found that. In fact, I was basing it in part on another PhD student at Georgia Tech at the time, was Betsy DeSalvo, and she had run this glitch game testers. So she was able to get a whole bunch of teen males interested in computing. All right, I'm going to switch back over to the Q&A then, since hopefully I answered that well enough. How can I improve teaching systems programming junior level courses? How can I improve teaching systems programming junior level course to be more inclusive? Easiest thing to start with is peer instruction. If you're used to just lecturing at your students, then at least break up lecture with peer instruction. Using more lower cognitive load practice like you can in an ebook is great. POGL is the other thing that I think I forgot to mention, is that I've also been doing is process-oriented guided inquiry learning in the ebooks, which is basically group work, but it's guided inquiry learning, so that I look at my lecture slides, for example, and I try to turn them into an activity the students can do and be hands-on with and still learn the same content. And then I'll ask them in the Padlet, what did you learn? What questions do you have? And if they've learned what I wanted them to learn, then that's great. In the Runestone system, I noticed there aren't any sound reinforcement. Is that because negative sound reinforcements make people feel like they're failing instead of learning? We haven't done a lot of audio, in part because, remember, our first book we were creating for AP teachers, and they don't like sound in a classroom full of people. So we did have audio tours because of the theory about that you have the dual channels, audio and visual. And so we thought having audio tours of code would be good, where we highlight one or more lines of code as we have audio playing that discusses them, but we didn't find people listen to them a whole lot. I spent hours creating these audio tours and very few people listened to them. Same thing with videos. When we add videos in the book, we found that very few people watch the videos. So we haven't really explored audio positive reinforcements or negative. I think that's all the questions I see at the moment.
Yeah, me as well. I think you tackled them all. And I think we're coming right up onto time. Unless you had any final statements, I can go ahead and close us out here.
Yeah, I guess I put in the chat ever the some of those links? I should have done that, I suppose. So I think I did put the Runestone links if people want to see more about that. Of course, my email I'll put in here too. You know, I'm happy for people to reach out to me and talk to me or my students. And I'm happy to share, Amber, my slides. They're up on Google Drive, so I can send you a link.
All right. Yes, that is. Oops. All right. Yeah, that's perfect. If you registered, as I mentioned earlier, you will get the slides and the video to your email within a week or so, probably the next few days. But I appreciate you again, Dr. Ericson. That was so interesting. It was hard to not listen to every word, and it was great. I really enjoyed it. So thank you so much, and you all have 5 minutes to the hour. Bye-bye.
Great. Thanks, everybody. Sorry for being late. Bye.
Bye.